Good day, dear colleagues. You can see topic of my presentation and the plan of my presentation. Electronic resources are widely used in the training of future chemists. Most often, these are visualization, it may be static and dynamic, which can reflect objects and phenomena close to their natural or abstract form, modeling tools, etc. Despite the huge educational potential of electronic resources, their use doesn't always increase the productivity, the quality of education. This is often due to a significant increase in the cognitive load of students with the suboptimal combination of educational material presented in different formats. I give you an example. Simultaneous demonstration of 4 windows in different formats leads to cognitive overloading. This work aimed to evaluate the value of cognitive load experienced by students learning organic chemistry topics using a textbook with different electronic resources. One needs to control changes in the cognitive load of students using electronic resources and take measures to prevent its excessive increase. There are known objective and subjective, direct and indirect methods to measure cognitive loads. In our opinion, the secondary problem method or the method of secondary task is optimal in education. How ICT-based was developed and used to quantify the level of cognitive load using this method. 49 third-year students of chemical department studied separate topics of organic chemistry presented in various formats. Text of different complexity, text with video, audio and animation in different combination. Simultaneously with the study of educational materials, respondents were periodically ordered to perform a secondary task. They must press a button when its color has changed as soon as possible. The faster the secondary task was performed, the less workload the respondent felt. The homemade software allows one to measure the time of respondents' response and process the results statistically. To see description of experiments, a total of 6 experiments were performed. The first was a blank experiment without a learning task. The other 5 experiments contain tasks in different formats. Such experimental schemes allowed us to achieve 3 goals. The first, comparison of cognitive load with when reading the text of different difficulty levels, experiment 1 and experiment 2. The second, comparison of the cognitive load caused by plain text and the text with video and the audio accompaniment or text with animation, experiment 1 compared to experiment 3 and 4. And the effect of video or audio distraction effects, experiment 5 compared with experiment 1 to 4. For each experiment, the reaction time T of individual students was determined and the average reaction time for a specific group of students. The relative values R were used to minimize the impact of students' individual characteristics instead of absolute values. Relative values normalized at the time of reaction of the blank experiment. It's known that the perception of different electronic resources depends on the preferred learning styles of students. Therefore, the learning styles of students using the Felder-Soloman method I investigate. Research of the index of learning styles includes survey respondents and the analysis of their responses to the 44 questions to assess the benefits for 4 additional aspects. A pair of style versus anti-styles characterizes each dimensions. Knowledge of learning preferences, allows us to establish correlation with cognitive loads when using different electronic resources. Such correlations will serve as a tool for optimizing electronic resources for teaching. Data verification by the Kolmogorov-Smirnov test indicates the presence of a normal distribution of the results of all experiments. The normality of individual data distribution allows us to operate with average values for analysis of the obtained results. You see descriptive statistics. Descriptive statistics give the average values of the reaction time for each experiment T. Calculates the relative values of the reaction time R. You see, the minimum load was absorbed in blank experiment and the maximum in experiment number 5. However, a simple comparison of average doesn't allow to determine whether the difference between them is statistically significant. You see, comparing the average by the t-test of paired sample, you can see 5 of the presented of 10 pairs demonstrate statistically significant difference in the cognitive load. Significant difference are marked in yellow with significance less than 0.05. Simple text experiment 1 produces less load than complex text experiment 2 and text with animation experiment 3. Video plus audio presentation experiment 4 involves low load that complex text 2, text with animation 3, and text with destruction video experiment 5. The learning profile of the students group in our experiments, you see in red, is very similar to that most typical of natural science students from theory in blue in our picture. It demonstrates the predominance of active, sensitive, visual, and sequential learning styles among the 4 available dimensions. The slide shows the presence or absence of significant differences in cognitive load for a whole group and the subgroups of students with particular learning preferences. For example, the difference between the loads exists for a whole group for 4 of the 5 experiments. For a subgroup of students with a preferred verbal style, a significant difference in workload exists only between experiments 1 and 4. To see the results of factor analysis, cumulative percentage of the explained variance by groups in percentage you see in this table. 2 main factors explained from 60, around 60 to 80 of the total percent. For example, you can ask me when learning styles are most influential for experiments 3 and 4. And you see there are 2 subgroups of students where the cognitive load in experiment 3 are either higher or lower than that in experiment 4. If R4 is less than R3, you see in the left in my picture, global styles is the most important and composes the factor 1, and the combination of verbal, intuitive, and active styles composes factor 2. If R3 is less than R4 in the right, active styles composes a factor 1, and combination of visual, intuitive, and global styles composes a factor 2. To be effective, the teaching methods and the complexity of the task for students must correspond to the students' perceptions. Points located on the diagonal or close to it in the picture, figure A, show a well-balanced learning process. In this case, the level of students' knowledge corresponds to the complexity of the task. Points located relatively far from the diagonal show learning situation characterized by inconsistency between task complexity and student expertise. Comparing figure A from theory, from model of notes, and our situation in B, we see that the complexity of the form of presentation of information contributes to the growth of cognitive loads. As a result, it requires a high degree of expertise from students to master the task of equal complexity. Obviously, this violates the results of mastering the material in a group of students. Last slide demonstrates you conclusions of our research, and I thank you for your attention.